Another tricky and hard cbse question. Show that the semi-vertical angle of a right circular cone of given surface area and maximum volume is sine inverse of 1 by 3. So we are talking about a cone. What is given is we are talking about the semi-vertical angle of a cone. Let this be the radius, this is the height, this is the slant height. We are given surface area. That means surface area is a constant. Whenever we are mentioned that about surface area, it is always the total surface area unless otherwise mentioned. So we are given S is equal to the total surface area is pi r square plus pi rl. We need to maximize the volume. The volume of the cone is equal to 1 by 3 pi r square h. We need to use this relation number 1 and bring volume in terms of one variable. So from relation 1, it is hard to find the value of R in terms of L, whereas it is easy to find the value of L in terms of R. So let us write pi RL is S minus pi RL is equal to S minus pi R square. So my L is going to be S minus pi R square divided by pi R. We have L in terms of S and R. S is a constant. Now we have to get this also in terms of only one variable. So let us replace this V as 1 by 3 V square. Let us square on both the sides. 1 by 9 pi square R power 4 H square. We will write this H square as L square minus R square. Now we have the volume in term. If V has to be maximum, V square will be maximum. So instead of differentiating V, we are going to differentiate V square. That's it. Now we have two variables here, L and R. But using this relation, L is equal to S minus pi R square by pi R, we are going to get this V square exclusively in terms of radius. So what is V square? 1 by 9 pi square R power 4 into, in the place of L, we are going to replace S minus pi R square by pi R the whole square minus R square. Maybe I think I will push this R power 4 inside the bracket and or I'll use the product rule. Let us just differentiate 2v dv by dr. Constant remains as it is. First let us differentiate this R power 4. We will get 4r cube into S minus pi r square by pi r the whole square minus r square. Next we'll keep r power 4 as it is and differentiate the expression inside the bracket. This gives me, I think we have to use quotient rule. So instead of using quotient rule, I think I will rewrite this as pi square r power 4 divided by 9 into, I will write this as s by pi r minus r the whole square minus r square. So that this differentiation of this is going to be easy for me. So we'll have r power 4. Derivative of this is going to be 2 times s by pi r minus r the whole power 1 into derivative of s by pi r. S by pi is a constant. Derivative of 1 by r is minus 1 by r square minus 1. This is the derivative of this term minus 2r. This is going to be the derivative. So for maximum volume, dv by dr should be equal to 0. That means this whole expression is going to be 0. So what does this give me? 4r cube. You can forget about the constant. So we have a big expression. Let me transfer it to the next slide. This big expression is going to be equated to 0. This big expression is going to be equated to 0 and that gives us a relation between S and R. That is what we are looking for. So I will replace it there. Let us see what happens. The derivative is here. This is the derivative. This is the derivative. So we are going to equate the derivative to 0. So when I equate it to 0, I think I can pull out a r cube common because I have a 4r cube and r power 4. I am left with a 4 into, I can write this also as s by pi r minus r the whole square minus r square inside the bracket. And r cube is being removed. So this will give me r times, there is a big bracket outside. Inside the bracket, I think I will multiply. I think I can pull out a 2 common. So I'll have a 2r here. S by pi r into minus s by pi r square will give me minus s square by pi square r cube plus sr by pi r square. So s by pi r. Then this product will give me minus s by pi r, and this gives me plus r, and I have, of course we have a minus r. I pulled out a 2 common, so we have a minus r, and this is equal to 0. Here we see that this expression is becoming simpler for us. So r cube cannot be 0, only the bracket expression should be 0. 4 times we have s by pi r minus r the whole square minus r square, then 2r into this term. So that is minus 1 r can be cancelled. So I'll have a 2s square divided by pi square r square is equal to 0. 4 cannot be 0, so I think we can't remove a 4. I think we have a 4 only for this particular term, and only there is a 2 that is common for this term. So I think I can get rid of a 2 or let it be there. 4 times s square by pi square r square. That plus r square minus r square will get cancelled. 2ab term will give me minus 2s by pi, and we have a 4 times this is equal to 2s square by pi square r square. So I have actually 4s square by pi square r square minus 8s by pi is equal to 2s square by pi square r square. This gives you 2s square by pi square r square is equal to 8s divided by pi. So we can cancel one s, we can cancel one 2, we can cancel one pi. So left hand side I simply have a s, right hand side I'll have a 4, then pi is cancelled, s is cancelled. I'm getting s is equal to 4 pi r square. I think going for the second derivative is going to be very hard. So we will just say that for maximum volume, second derivative is going to be d square v by dr square, maximum volume less than 0 when s is equal to 4 pi r square. We need to prove that the angle is sine inverse 1 by 3. So now what we are going to do is, we are going to go to this expression number 1. S is equal to pi r square plus pi rl. But for maximum volume, we have justified s is going to be 4 pi r square. So we will get 4 pi r square is equal to pi r square plus pi r l. We can remove a pi r everywhere. I'll get a 4r is equal to r plus l. I'll get l is equal to 3r. Slant height is equal to 3r. So what is h? L square is equal to r square plus h square. So I will get h also in terms of, we need sine inverse. Sine is going to be opposite side. I think we have got from this result itself, we have got the answer. So L r by L is equal to 1 by 3. But if you go to the diagram, if you call the semi-vertical angle as theta, we know that sine theta is equal to opposite side by hypotenuse. Sine theta is equal to r by L. So we get sine theta is equal to 1 by 3. Theta is equal to sine inverse of 1 by 3. I wouldn't rate this question as a very tough question, but looks like pretty lengthy question.